I'm Anil Kumar. In this particular video, we'll see how to solve a triangle when two angles and a side is given to us. In a triangle RST, angle S is equals to 51 degrees, angle T equals to 63 degrees, and the side T is 15.2. Find R in two different ways. So let's make a triangle. Let us say that the base is ST, right? So let's take base as ST. So one of the angles given to us is 51.51 degrees. Let me write S as 51 degrees, T as 63 degrees. Well, the scale, it is not to the scale. What we need to find is the side opposite to T, which is small. That is given to us, T is given to us as equal to 15.2. R, we need to find the side small r, which is opposite to angle R. Now you can actually solve this triangle using sine law, and you can also solve this triangle with making a right triangle inside. I'd like you to pause the video, answer this question, and then look into my suggestions. Let us first apply sine law. We can find the third angle, 180 minus 51 and 63. So 180 degrees, take away 51, take away 63 degrees is equal to angle R, right? So let's write angle R is equal to that much. 180 minus 51 minus 63 gives us 66 degrees. So this is 66 degrees. Since we have a combination of side and an angle, opposite side and angle, we can apply sine law. So from sine law, we know R, the side, opposite to angle 66 degree. So sine of 66 degree is equal to the combination known to us, side length 15.2 divided by sine of 63. So from here, R is equals to 15.2 times sine of 66 degrees divided by sine of 63 degrees, right? So we get 15.2 times sine of 66 degrees divided by sine of 63 degrees is equal to 15.58, right? We can round this answer to one decimal place. Let's round it to one decimal place since this is one decimal place. So I'm using 15.6 units as my answer. Now that is one way of doing it. We applied sine law and solved the triangle. How else can you do it? Well, what we can do here is that we can draw a perpendicular from R to the opposite side. So if that is perpendicular, we know one of the sides, right? So using the triangle, let us say this perpendicular is at point Q. In that case, SQR triangle is a right triangle. Correct? So we can find SQ, since SQ over SR is equals to cos of 51 degrees, right? So SQ can be written as SR is 15.2 times cos of 51 degrees, right? So we get SQ from here. So that gives you 15.2 times cos of 51 degrees. That is equal to let's keep it 9.56 for the time being. Now from here, we now know this side. We have to figure out what that side is. What we can do is we can find RQ also using sine, right? So RQ will be equal to 15.2 times sine of 51 degrees, since that is the opposite side to 51, right? So that gives you 15.2 times sine of 51 degrees. That gives you 11.81. So we know this side is 11.81. Since we know this is 11.81, we can find what QT is, right? We can find QT using tan of 63, right? So tan of 63 is equal to 11.81 over QT. That gives you QT equals to 11.81 divided by tan of 63 degrees, correct? 11.81 divided by tan 63 degrees is 6.01. So we get 6.01. So now we know what is SQ and what is QT. So ST, which is R, so R, which is equals to ST, is equals to SQ plus QT is equal to 9.56 plus 6.01, right? So 6.01 plus 9.56 gives us 15.66. Right? So 15.6 is our approximate answer, so that is the answer, right? So we can actually find the solution in two different ways, as shown here, treating them as the right triangle. So we can say R is approximately equals to 15.6. Right. So I hope the steps are absolutely clear. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thank you and all the best.